लाइक, शेयर, सब्सक्राइब ये इस चैनल के 3 स्तंभ हैं। इन्हें दबाइए और आगे की वीडियो को एंजॉय करें।
Namaste and welcome back. In any predictive modeling problem, we have seen that the first step is to understand your data. We have to understand our data to solve any of the problem. But the question arises that how do we understand the data? Okay, we have data. Okay, I have my data. Now, what should I do to understand the data? For that, we use some of the techniques like statistical description of the data, some of the exploratory data analysis, univariate analysis, bivariate analysis. So in this video, we are going to see some of the statistical descriptions of data. There are two types of descriptions. One is related to the central tendencies and one is related to the dispersion of data. This is the part 1 of the video, and in the next video we will see the descriptions related to the dispersion of data. So let's start with the central tendencies. So let's start our discussion on the statistical description. Basically, there are two types of statistical description we are concerned about. The first one and the second one. First one is the central tendencies. Central tendency. Okay, and the other is the dispersion of data. So in these two types, we see the statistical description of our data, and in the central tendency, we usually talk about the 3 M's, that is the mean, median, and mode. Okay, so a single number representing the characteristics of data, while in the dispersion of data we see something like variance, standard deviation, quartiles, okay, interquartile, range, and of course range of the data. So in the central tendencies, we are concerned with some of the average value, some of the middle value, and some of the most occurring value. And in the dispersion, we see how the data is dispersed, what is the range of data, variance of data, quartiles and interquartiles range. So let us start our discussion on these 3 things in this video, and then we will continue to these things in the next video. So first of all, let us see what is mean is. So I am talking about mean, and these are things that we know from our 10th and 12th standard. So the mean is if we have x1, x2, x3 up to xn observation, then mean or mu is calculated as summation xi's, sum of all observation, divided by total number of observation. This is mean. Then we have median. So to calculate median, we have 2 steps, or the median is the middle value of the entire data. So to calculate median, first we arrange the data in ascending order, and then we see the middle element or the central element of the distribution. And once we have arranged the data in the ascending order, we have the formula that it is the n plus 1 by 2th term if n is odd, and it is the average of n by 2th term plus n by 2 plus 1th term by 2, of course the average, if n is even. So this is how we can get the median of the data. And the third one is the mode, that is the most occurring value in the data. Okay, this is the mode. So mean is the average, median is the central value of the data if arranged ascending order, and mode is the most occurring or frequently occurring value. Now let us take an example and see the impact of outlier on these central tendencies. So let us take an example that we have 1, 2, 3, 4, 5, and of course we have these 5 values. So it is simple that the mean value of these 5 numbers would be 3, because 1 plus 2 is 3, 3 plus 3 6, 6 plus 4 10, 10 plus 5, 15, and 15 divided by 5, we have mean is equal to 3. Okay, and the median where n is 5, that means it is odd numbers. So we will have n plus 1 by 12th term, that is 5 plus 1, that is 6, by 2 divided by third, that means 3, that is the third term. So we have median is equal to 3. Now let us add a number, that is 105 to this. Okay, let us add 105. Now we can see that the numbers are 1, 2, 3, 4, 5, and there is another number, that is 105. So if I talk about, let us say these are the rating of a movie in 1, 2, 3, 4, 5, then 105 will of course act as an outlier. So now if we calculate the mean, then the sum of these numbers would be 15. 15 plus 105, that is 120, and 120 divided by 6, that is 20. So the mean becomes 20. New mean becomes 20. If we check the median, so the median is n is even now because we have 6 terms. So third term plus fourth term divided by 2. This is the third term, this is the fourth term divided by 2, that is 3.5. So the new median is 3.5. So I can say that the mean is greatly affected by any outlier present, and median is robust to the outlier. So this is an important statement, that mean is affected by outliers, while median is robust to the outliers. Now let us check about mode. If we have 1, 1, 1, 2, 2, 3, 4 and 5, then mode would be the most frequently occurring value, that is the 1. So mode is equal to 1. Now if I add 105 here, my mode will not change. Okay, if I add another outlier 1000, 10,000, then also my mode will not change. Hence I can say that mode and median are robust to outliers. This is the important statement dealing about outliers, because when we are understanding the data, we are plotting mean, medians and mode, it is very important that our distribution of data doesn't contain any outlier. If it contains some outlier, then mean value would not represent very interesting things. But of course median and mode represent the actual values. They are not greatly affected by any outlier present. So we have seen the central tendency, that is the mean, median and mode, in this video. In the next video we will see range, variance, standard deviation, quartiles and interquartile range, that represents or or tell us the information about dispersion of the data. And just summing up, that mean is not robust to outliers, while median and mode are robust to the outliers.